If I ask you about how many explosive compounds you are familiar with, I'm sure most of you will remember TNT. TNT is a legacy explosive and it has a cousin family too. We know them as insensitive high explosives, which have been developed by the defense industry to maintain a high performance and easier handling in the same time. Today, I will specifically talk on 2,4-dinitroanisole or DNAN, which is one of the insensitive high explosives and is being used as a replacement for TNT due to its excellent detonation characteristics. However, there are some contamination issues with the post-detonation residues of DNAN. But why is it a concern? Because DNAN is a poorly water-soluble compound and it has relatively low adsorption in soil, which means if it enters the environment, it will act as a source of continuous pollution for years. Among different treatment technology, ex situ remediation or dredging is expensive and it has some serious safety concerns when the soil is contaminated with high concentration of explosives. Previous researchers found that DNAN can undergo alkaline hydrolysis, but the process requires extremely high pH and it can render the soil pH too high, and we don't want that. So we need to look for an alternative approach to degrade DNAN faster without facing all these challenges. So here we are introducing to Pyrogenic Carbonaceous matter or PCM, which are basically carbon amendments that have been used to remove contaminants from aqueous phase by adsorption historically. Our goal is to use PCM to couple hydrolysis with adsorption to make a faster DNAN degradation at a relatively low pH. So we used graphite, which is a model PCM. And we saw a faster DNAN degradation in the room temperature at a relatively low pH. Next, we used several other PCMs like biochar made out of almond shell, activated carbon. We even modified the activated carbon physically and chemically. And our results showed that the chemically modified activated carbon performed the best, showing the faster DNAN degradation, which is above 90% in 7 days. Finally, we looked into the product formation for all these reactions going. And we saw that the presence of PCM can produce less toxic product when no PCM hydrolysis can produce more toxic product than the DNAN itself. Hence, we anticipate that these findings will have broad implications in remediation technology. Thank you.